But let's move on to concatenating along an axis. Let's just create a new ND array here, 3 by 4 matrix, and we'll use the NumPy concat method in order first to stack these. So let me move this aside and you'll see what I mean. We're going to stack along the default axis, which is the 0 axis. And you'll see here's the first instance of this array, and then we've concatenated this same array to itself. So we have a second instance stacked up together. Now if we put this axis equals 1 back in here and run this again, what concatenate has done is stacked these two again, but they've done them side by side rather than on top of each other. Of course, you could change this to axis equals 0, and it's going to stack them again. But as we explored previously, we know that NumPy operates along the 0 axis by default, so this is redundant and unnecessary. Let me change this back to 1 and run that again. Notice the different syntax here for concatenation in NumPy. Rather than say concatenate, we just say concat, and we're going to concatenate these 3 series together, and the result is going to be predictable. Cat and dog was the first series, and we have that here. Cat, dog, and pig is the second series. That's right here. Fish and goat is the third series. It just concatenates them one on top of another. Let's create a new series by concatenating series 1 and series 3 together, and let's rename this series 4. If we run that, we get an expected outcome. So let me put this axis 1 in here. Axis 1 will create a data frame with empties. So we have actually created a data frame here by concatenating these 2 series on axis 1. Now that we have series 4, if we return this to a 0 axis concatenation, and then if we concatenate series 1 into series 4, and remembering that series 4 already has series 1 and series 3, we'll get a result similar to what we got up here. But what happens if we use axis 1 in here now? Let's run that. And since series 1 only had 2 values and series 4 had 4 values, we get empties here in fish and goat where there was no matching values. Down here we're going to create a hierarchical index. So we're going to set some hierarchical keys 1, 2, and 3. Let's run this. And you might be wondering, why didn't we get a hierarchy? Well, that's because we've included this axis 1 in here, and we stacked them alongside each other. Let's remove this and run this again, and there's a hierarchical index. Now if we unstack this, we get our level 1 index as column labels, and we get our level 0 index as row labels. But if we put axis 1 back in here again, and run this, notice the difference. We get a data frame here, just as we'd expect. You're stacking these together on axis 1 side by side, and we get empties at all of the same data points, but our column labels and our row labels are reversed. I would encourage you to take time and explore this behavior so you can get a little bit intuitive about it. Let's collapse some of this output. And that'll make it easy for us to see our original setup here. In this code cell, we're going to concatenate series 1 with series 3. These are of matching dimension. We're going to concatenate series 1 with series 4 again, and remember that series 4 was simply the concatenation of series 1 and series 3. So what we have in series 4 is cat, dog, fish, and goat. And then in series 1, we're going to add cat and dog again. If we do that without any other arguments, see we get cat and dog twice with the same indices, and then we get fish and goat as expected. Now if we run axis 1 on that, we'll get the same result as we got here. This is going to stack these side by side. And cat and dog, of course, have values in both, but fish and goat have empties in this 0 column. Now you'll probably recall that above, when we used merge, we used a how is equal to inner, in order to get an inner join. But with concatenate, we have to use join is equal to inner instead of how is equal to inner. And if we run this, we'll only get cat and dog because those are the values in the intersection. What do you think happens if we put outer in here? We run that. Then we get the entire expected output.